Assalamu alaikum wa rahmatullahi wa barakatuh. You are all welcome to physics class today. Today's discussion is going to be centered on measurement of temperature. So today we want to learn about temperature of bodies. We know about temperature of a normal human being, a human being that is healthy. We know a temperature of an healthy human being and what could be the temperature of someone that is sick. We are going to know what are the devices that can be used to measure temperature and so on. But out of what I've talked about, we have some areas we are going to focus on today. So at the end of this class, we are going to be able to, first of all, define temperature. It is very important we know how to define temperature, after which we are going to be able to state the SI units of temperature. There are up to 3 units or 3 scales upon which temperature can be measured. And the last part of what we are going to be doing is to be able to convert from one temperature scale to another and also identify the absolute zeros of temperature scales. These are what we are going to be discussing in this time and what we should be able to understand at the end of our discussion. So going into the discussion, what is temperature? As we all know that temperature can be defined as the degree of hotness or coldness of a body. That is simple definition of a temperature. Temperature can also be related to the kinetic energy of a body. It therefore means that temperature is directly proportional to the average speed or kinetic energy of the molecules of a substance. This is telling us that the higher the kinetic energy of a body, the higher the temperature, and vice versa. Alright, so what you have here is that temperature is proportional to kinetic energy, or you can say temperature is proportional to the average speed of molecules of a body. So this statement is confirming the variation above. The higher the temperature, the greater the average speed or kinetic energy of molecules and vice versa. Alright, we are done with the first agenda. We are going to the second agenda, which is to be able to state the SI units of temperature. There are 3 SI units for temperature. The first one is degrees Celsius. We have degrees Celsius. Number 2, we have Fahrenheit. Number 3, we have Kelvin. These three units are what we can be used to measure the temperature of a body. Now, degrees Celsius we have here, we should understand that for degrees Celsius, we have a freezing point of water to be 0 degrees Celsius and the boiling point of water to be 100 degrees Celsius. That is for Celsius scale or Celsius unit. We also have for Fahrenheit, the freezing point of water on Fahrenheit scale is 32 degree Fahrenheit and the boiling point is 212 degree Fahrenheit. While for Kelvin, the freezing point of water on Kelvin scale is 273 Kelvin, while water boils at 373 Kelvin. So these boiling point and freezing point on the different units for scale are very, very important to understand because they are going to be used when it comes to other aspects of discussion. Right, we are moving to the third agenda. The first agenda is to define temperature. The second lesson objective is to state the units of temperature, and the last part of it is to look at how we can convert from one temperature scale to another temperature scale. Actually, we have three temperature scales and the 3 scales are Fahrenheit scale, Celsius scale and Kelvin scale. And we can see on the scale, you can see the freezing point of water on the scales, and you can see the boiling point of water on the scale. You can see it varies from one scale to another. But what this one simply means that on Fahrenheit scale, 32 degree Fahrenheit is equivalent to 0 degrees Celsius on Celsius scale, and that is equivalent to 273 Kelvin on Kelvin scale. Then for boiling point, it means that 212 degree Fahrenheit on Fahrenheit scale is equivalent to 100 degrees Celsius on Kelvin on Celsius scale, and that is equals to 27373 Kelvin on Kelvin scale. Alright, so these are scales of temperature. Then what we need to understand next is how we can move from one scale to another, how we can convert one scale to another. That is another point of discussion, and there are formulas. There are formulae in which we are going to be using to move from one scale to another. Okay, the first one is, let's say we want to convert from Celsius to Kelvin. The formula is T Kelvin equals T Celsius plus 273. This must be memorized. T Kelvin equals T Celsius plus 273. That is it. If you want to convert from Kelvin to Celsius, T Celsius will be equals to T Kelvin minus 273 Kelvin. So I have only made T Celsius here subject of the formula. Then I'm going to have the second equation. Right. Now, when we want to move from Fahrenheit to Celsius, we are moving from Fahrenheit to Celsius. The formula here is T Celsius equals 5/9 open bracket T Fahrenheit minus 32 close the bracket. That's the formula that can be used to calculate to convert Fahrenheit to Celsius. And another possible equation is T Fahrenheit minus 32 over 1.8. So it depends on which one you can recall quickly. Is that you use this part of this one, or you use this other equation. So converting from Celsius to Fahrenheit, you are going to use an equation T Fahrenheit equals 9/5 times T Celsius plus 32. That is the equation for converting Celsius to Fahrenheit. Or you use 1.8 times temperature in degrees Celsius plus 32. So you can use any of the two equations. So we have now understood the scales of the temperature scales, and we can now recall the equations to move from one temperature scale to another. So let's look at some worked examples. Look at the first example here that says convert 25 degrees Celsius to degree Fahrenheit. Convert 25 degrees Celsius to degree Fahrenheit. So it means that we are moving from Celsius scale to Fahrenheit scale. The formula is going to be T Fahrenheit equals 9/5 times T Celsius plus 32. That is the formula, if you can remember. Look at it. T Fahrenheit equals 9/5 times T Celsius plus 32. And your T Celsius is 25. So all you need to do is substitute 25 here, and you get 9/5 times 25 plus 32, and that's going to give you 45 plus 32, and that's going to give you 77 degrees Celsius. So therefore 25 degrees Celsius is equals to 77 degrees Fahrenheit. So this is the second example. We are asked to convert 0 degrees Celsius to degree Fahrenheit. 0 degrees Celsius, as you know, its equivalent on Fahrenheit scale is 32 degrees Fahrenheit. We have said that earlier. So let's see how we are going to get that. You recall the equation. You are converting Celsius to Fahrenheit just like you did in number 1. So we are going to use the same formula, and our degree Celsius is 0 given from the question. All you need to do is to substitute. That will now be 9/5 times 0 plus 32, and that will give you 0 plus 32, and that is 32 degrees Fahrenheit, which is the freezing point of water. And the last example is to convert your body temperature, which is 98.6 degrees Fahrenheit to degrees Celsius. And a healthy human being has a temperature of 98.6 degree Fahrenheit, and its equivalent in Celsius is around 36.5 degrees Celsius or 37 degrees Celsius. So if you are asked, you should know is that in Fahrenheit, a normal temperature of human being should be 98.6 degree Fahrenheit or approximately 37 degree Celsius. So let's see how we can convert this to 37 degrees Celsius. You use the equation, you are converting Fahrenheit now to Celsius. So degrees Celsius equals 5/9 open bracket T Fahrenheit minus 32. Your Fahrenheit is 98.6 minus 32. That will give you 66.6 times 9/5, and that will be 37 degree Celsius. So we can now see how we convert from one temperature scale to another. So all we need to understand here are the converting equations, and then when you have a problem, you know how to substitute, then operate with the calculator and get your result, inshallah. Right, we have these activities for you. First one is to convert a warm spring day's temperature of 78 degree Fahrenheit to 0 degrees Celsius. The supposed answer is this. And the other one is convert the temperature of a winter day at North Pole, which is minus 40 degrees Celsius, to both Fahrenheit and Kelvin. So you convert this to Fahrenheit, you convert this to Kelvin. These are the supposed answer, right? And the last one says, what is the equation relating Celsius scale and the Kelvin scale? This can be seen in one of the slides that we have discussed above. Now moving on to the last part, which is absolute zero. Absolute zero, we want to know what is absolute zero or absolute temperature, and know how we can identify them or what are their values on the temperature scales that we have. What is absolute zero or absolute temperature? Absolute temperature is the lowest possible temperature of a body. This is a temperature that a body cannot get colder. A body cannot get colder than absolute temperature, absolute zero. So absolute zero or absolute temperature is the lowest possible temperature of a body. And at this temperature, the kinetic energy of the body is set to be zero. That is, there is no movement of the molecules of the body. The particles of the body or the molecules of the body are still. They are not moving because there's no kinetic energy moving there's no kinetic energy in the body. At that point, the body is said to be in absolute temperature. So in statements, in statements you have it on the board. This is the lowest possible temperature when nothing can be colder and no thermal energy remains in the substance. Absolute zero is the point at which molecules do not move and possess no kinetic energy. So this is at lowest temperature, kinetic energy is zero, and particles or molecules do not move in the body. Right. So if you look at these three scales, you can see that the Fahrenheit scale, the absolute zero is minus 459 degree Fahrenheit. On Celsius scale, it is minus 273 degree Celsius, and on Kelvin scale, it is 0 Kelvin. So Fahrenheit minus 459 degree Fahrenheit, on Celsius minus 273 degree Celsius, and on Kelvin scale 0 Kelvin. If you look at the freezing point on Fahrenheit, it is 32 degree Fahrenheit. It is 0 degree Celsius on Celsius scale. It is 273 Kelvin on Kelvin scale. Then for boiling point, it is 212 degree Fahrenheit on Fahrenheit scale. It is 100 degrees Celsius on Celsius scale, and it is 373 Kelvin on Kelvin scale. Kelvin is the most used scale among scientists of the world, and there are two reasons for that. One, Kelvin has no negative value. You will see only Celsius and Fahrenheit have negative values. No negative value on Kelvin scale. And again, Kelvin has no degree. There is no degree on Kelvin scale. We can see degree on Celsius and Fahrenheit scale. I think we have come to the end of this class. And what we did. One, we defined temperature as the degree of hotness or coldness of the body. And we said can also be defined in terms of kinetic energy, which means that temperature can also be defined as the measure of average kinetic energy of a body. It means the higher kinetic energy of a body, the higher the temperature, and vice versa. We equally look at the units for measuring temperature. We have the Celsius, we have the Fahrenheit, we have the Kelvin, and we said that on Celsius scale, the boiling point is 100 degrees Celsius, while melting point is 0 degrees Celsius. On Kelvin scale, the boiling point is 373 Kelvin and melting point is 273 Kelvin. On Celsius scale, on Fahrenheit scale is 212 degree Fahrenheit, and that's the boiling point. The melting point is 32 degree Fahrenheit. And then we look at the converting formula, how we can convert from one temperature scale to another. And I said the scales that we have for measuring temperature are Fahrenheit scale, Celsius scale, and Kelvin scale. Then we look at the absolute zero, that is the lowest possible temperature a body cannot get colder, and that at that point the kinetic energy of the body is zero and the molecules of the body do not move, they are still. And we look at their values, the value of the absolute zeros on the three scales. We said on the Fahrenheit, the absolute zero is -459 degree Fahrenheit. On Celsius is -273 degrees Celsius, and on Kelvin is 0 Kelvin. And I said Kelvin is the most widely used scale among others in the midst of the science of the world. And there are two features that make that possible. It has no zero units, it has no zero value, it has no negative value, and it has no degree. It is not expressed in degree. And that increases us in revolutionary knowledge. You have to listen to watch this video over and over again for better understanding. Assalamu alaikum warahmatullahi wabarakatuh.